YouTube script, building a robust AI model deployment pipeline, from development to production-ready systems. Intro. Scene opens with an upbeat music track, showcasing visuals of AI technologies in action, like robots, machine learning graphics, and data analytics. Cut to the host standing in a modern office. Host, welcome back to our channel. Today, we're diving into a topic that's crucial for anyone working with artificial intelligence: building a robust AI model deployment pipeline. Whether you're a seasoned data scientist or just stepping into the field, understanding how to transition your AI model from development to a production-ready system is key to harnessing the full potential of AI. So, let's get started. Transition. Host, before we jump into the nitty-gritty, let's clarify what we mean by an AI model deployment pipeline. In essence, it's the series of processes and technologies that allow you to take an AI model, which is usually developed and tested in a development environment, and deploy it into a production environment where it can be used by real users or systems. This pipeline ensures that your model is not only functional but also efficient, reliable, and scalable. Section 1: Understanding the AI Model Lifecycle. Host, to set the stage, it's essential to understand the AI model lifecycle. This lifecycle typically consists of several stages: data collection, data preprocessing, model training, model evaluation, and finally, model deployment. While each stage is critical in its own right, we're going to focus on the deployment phase today, discussing how to make your model production ready. Scene shifts to graphics illustrating the AI model lifecycle stages. Host, in the deployment phase, you need to consider how your model will interact with real-world data and how it will be accessed by end users or applications. This is where a robust deployment pipeline becomes indispensable. Section 2: The components of a deployment pipeline. Host, now, let's break down the components of a robust AI model deployment pipeline. There are several key elements that you should include to ensure a smooth transition from development to production. Scene cuts to a flowchart displaying deployment pipeline components. Host, first, we have version control. Just like software development, your AI models need to be versioned. Using tools like Git for code and DVC for data and model versioning can help you keep track of changes and ensure reproducibility. Every time you refine your model or tweak the data, you should create a new version. Host, next up is continuous integration and continuous deployment, or CI/CD. CI/CD practices allow you to automate the deployment process, making it easier to push updates and ensure that your models are always in sync with the latest code. Tools like Jenkins, CircleCI, or GitHub Actions can help streamline this process. Host, another crucial component is containerization, which involves packaging your AI model and its dependencies into containers using tools like Docker. This ensures that your model runs consistently across different environments, whether it's on a local machine, in a testing environment, or in production. Host, finally, we have monitoring and logging. Once your model is deployed, it's essential to keep an eye on its performance. Tools like Prometheus or Grafana can be used to monitor key metrics, while logging frameworks like ELK-Stack help capture logs for troubleshooting and optimization. Section 3: Creating a deployment strategy. Host, with the components of your deployment pipeline in place, it's time to establish a deployment strategy. This strategy will outline how you'll roll out your AI model to users. There are a few common strategies you might consider. Scene shows a list of deployment strategies. Host, the first is the blue-green deployment approach. In this strategy, you maintain two environments, one for the current version of your application and another where the new version is deployed. Once the new version is tested and verified, you simply switch the traffic to the new version, ensuring minimal downtime. Host, another approach is canary deployment. Here, you release the new model to a small subset of users first, allowing you to monitor its performance and address any issues before a full rollout. This helps mitigate risk and ensures that any unforeseen problems are caught early. Host, lastly, consider the rolling update strategy. This involves updating your model incrementally across your servers. While this approach can take longer, it allows you to update your model without affecting all users simultaneously. Section 4: Ensuring data integrity and security. Host, as we move closer to actual deployment, we can't overlook the importance of data integrity and security. In a production environment, your model will interact with live data, which can pose risks if not handled correctly. Scene transitions to visuals of data flow and security measures. Host, to ensure data integrity, implement strict data validation checks before the data is fed into your model. This involves checking for missing values, outliers, and ensuring that the data meets the expected format. This is crucial, as garbage in often leads to garbage out. Host, security is another vital aspect. Ensure that your model's API is secure, using authentication mechanisms to protect against unauthorized access. Encrypt sensitive data both in transit and at rest. Regularly update your security protocols to patch vulnerabilities. Section 5, Performance Optimization. Host, once your AI model is deployed, you'll want to ensure it performs optimally. Performance optimization can involve several strategies. Scene displays various optimization techniques. Host, one common method is to optimize your model's architecture. This may involve reducing the model size or simplifying the algorithms to decrease inference time without compromising accuracy. Tools like TensorFlow Lite or ONNX can help you achieve this. Host, another approach is to leverage batch processing for inference. Instead of processing one request at a time, you can group multiple requests together, allowing your model to handle data in bulk, which can significantly improve throughput. Host, lastly, don't forget to revisit your model periodically. The world changes, and so do patterns in the data. Regularly retraining your model with new data will ensure it remains relevant and continues to perform well. Section 6, Testing and Validation. Host, before fully deploying your model, testing and validation are crucial steps that shouldn't be overlooked. You want to ensure that your model performs well under real-world conditions. Scene shifts to visuals of testing scenarios. Host, start with unit testing for your code and integration testing to ensure that all components of your deployment pipeline work together seamlessly. Use A/B testing to compare performance between different model versions and determine which one meets your performance criteria. Host, additionally, consider using synthetic data to test your model in scenarios where real data might be limited or unavailable. This can help you identify potential weaknesses and make adjustments before full deployment. Section 7, Documentation and Training. Host, as you finalize your deployment pipeline, don't neglect documentation and training. Proper documentation ensures that your team members understand the deployment process and can troubleshoot issues if they arise. Scene shows hosts flipping through a documentation guide. Host, include clear instructions on how to deploy the model, manage updates, and handle logging and monitoring. Furthermore, consider conducting training sessions for your team to familiarize them with the deployment pipeline, tools, and technologies you've employed. Section 8, Scaling Up. Host, finally, as your AI system gains traction and user demand increases, you'll need to consider scaling up your deployment pipeline. Scene transitions to visuals showing scaling infrastructure. Host, cloud platforms like AWS, Google Cloud, or Azure offer scalable solutions that allow you to adjust resources dynamically based on user demand. Implement load balancing to distribute traffic evenly across multiple instances of your model, ensuring consistent performance. Host, remember, scaling isn't just about handling more users, it's also about maintaining model performance and reliability. Keep a close watch on your monitoring dashboards to identify when it's time to scale up or down. Conclusion. Host, and there you have it. Building a robust AI model deployment pipeline involves careful planning, the right tools, and ongoing maintenance. Whether you're starting from scratch or refining your existing processes, following these steps will help you ensure that your AI models are ready for the real world. Scene shifts to host wrapping up. Host, if you found this video helpful, please give it a thumbs up and subscribe for more content on AI and machine learning. Also, drop your questions in the comments below, and I'll do my best to answer them. Until next time, happy deploying. Outro music plays as the screen fades to a channel logo, and video suggestions pop up.